What if one of the biggest breakthroughs in modern physics didn't come from a celebrity scientist, but from someone the world barely noticed at first? Imagine solving a mystery that even Albert Einstein couldn't crack, only to be ignored for years. That's exactly what happened to John Stuart Bell. He found something that shook the very core of quantum mechanics, but at the time, no one believed him. Not because he was wrong, but because what he discovered was too strange to accept. This is the story of how one man quietly changed science forever and why it took the world so long to notice. 10. John Bell wasn't who you'd expect. John Bell didn't come from the elite class of famous physicists. He was born in Belfast, Northern Ireland in 1928 and came from a working-class family. He wasn't flashy, he didn't seek fame, and he wasn't part of the academic elite. He studied physics and got a job at CERN, the big particle research center in Switzerland. There, he mostly worked on particle accelerators. Important work, but not the kind that usually leads to a scientific revolution. Bell, though, had a quiet obsession with something far stranger: the rules of quantum mechanics. While most scientists were satisfied with using quantum theory to make predictions, Bell wanted to understand what was really going on behind the scenes. He didn't think the current theory explained everything. He thought something deeper was missing. 9. The strange world of quantum physics. Quantum physics is the branch of science that deals with the tiniest building blocks of our universe: atoms, particles, energy, and forces. One of the weirdest features of quantum mechanics is how particles seem to exist in multiple states at once until they're measured. Another strange behavior is entanglement. When two particles are entangled, measuring one seems to instantly affect the other, even if they're light years apart. It sounds like magic, but experiments show it really happens. Albert Einstein didn't like this. He believed that God does not play dice with the universe. He thought the randomness in quantum physics was just a sign that we didn't have all the information. He suspected there were hidden variables that we couldn't see, which would explain why particles behave the way they do. Bell agreed with Einstein, but instead of just talking about it, he decided to actually test the idea. 8. The question nobody could answer. By the early 1960s, most physicists had moved on from Einstein's concerns. They were happy using the math of quantum theory to build lasers, computers, and other useful technologies. But Bell kept coming back to the same question: is quantum theory telling the full story? Or is it just an incomplete model that hides a deeper reality? Bell realized that if Einstein's idea of hidden variables was right, it would change how we understand everything, from atoms to entire galaxies. But there was a problem. No one had ever figured out how to test for hidden variables. It was like arguing over something you couldn't measure. That's when Bell had his breakthrough. 7. Bell's theorem changed the game. In 1964, Bell published a paper with a quiet title that didn't draw much attention at the time, on the Einstein-Podolsky-Rosen paradox. But what was inside that paper would eventually rock the scientific world. Bell figured out a way to test whether hidden variables were real or not. He created something now known as Bell's theorem, a mathematical formula that shows the difference between the predictions made by quantum mechanics and those made by any theory with hidden variables. This wasn't just philosophy anymore. Bell had created an actual test. If experiments matched his formula in a certain way, it would mean hidden variables couldn't explain quantum behavior. In other words, the universe really was as weird as quantum theory says. The idea that information can instantly travel across vast distances, or that particles don't have fixed properties until observed, would no longer be just a theory. It would be a fact. 6. At first, no one listened. When Bell published his paper, it barely made a ripple. The physics community had mostly stopped worrying about the deeper meaning of quantum mechanics. They were busy building nuclear reactors, exploring space, and working on more practical problems. Bell wasn't famous. He wasn't part of a major academic movement. And honestly, his ideas sounded too strange to take seriously. To many scientists, quantum mechanics worked just fine. It predicted results accurately and helped power new technology. Why mess with it? Bell's ideas were viewed as a kind of fringe interest. Only a small number of physicists, like David Bohm and later Alain Aspect, took his work seriously. 5. The experiments that proved him right years went by before anyone tested Bell's idea. Then in the 1970s and 80s, French physicist Alain Aspect and his team ran a series of experiments using entangled photons. These tests measured whether Bell's inequality, the formula he had developed, was violated. The results were shocking. The experiments didn't just break Bell's inequality, they crushed it. Quantum physics was right. Hidden variables, at least the kind Einstein imagined, couldn't explain the results. Bell had been right all along. The universe really is connected in strange ways that can't be explained by local, hidden causes. This meant that when two particles are entangled, something beyond our normal understanding of space and time links them. It's not just weird, it's fundamental. 4. He never got the Nobel Prize. You'd think that someone who changed our understanding of the universe would be celebrated everywhere. But Bell didn't get the kind of recognition he deserved during his lifetime. He died in 1990 of a sudden stroke, just before he was rumored to be a top candidate for the Nobel Prize. The Nobel Committee is known for being careful, especially with ideas that sound radical. Since Bell's work dealt with the foundations of physics rather than a new invention, it may not have seemed practical enough at the time. But today, his name is everywhere in physics textbooks and quantum computing research. 3. His work inspired a new generation. Though ignored at first, Bell's ideas sparked a wave of interest in quantum foundations. Scientists like David Bohm had already been working on alternative theories, but Bell gave them a way to test those ideas. More recently, his work has become a major part of the rise of quantum information science, a field that includes quantum computing and quantum encryption. Today, Bell's theorem is more than just a physics curiosity. It's used to test whether quantum computers are working correctly. It helps researchers design systems that are truly random, and even secure communication channels that can't be hacked. All of this started with Bell's quiet challenge to the physics world. 2. He challenged the idea of reality itself. Bell didn't just create a formula, he raised a deep question that science still hasn't fully answered. What is reality? If particles don't have definite properties until they're measured, then what is the universe really made of? Are we shaping reality by observing it, or is there something else going on? These are the kinds of questions that physicists still wrestle with today. The debate over how to interpret quantum mechanics is far from settled. Some believe in multiple universes, others believe consciousness plays a role, but none of this would even be on the table without Bell's work. He made it okay to ask the uncomfortable questions again. 1. His legacy lives on. John Bell didn't solve the mystery to become famous. He did it because he wanted to understand how the world works. And even though he wasn't believed at first, his work now stands as one of the most important contributions to physics in the 20th century. His legacy lives on in every quantum computer being built, in every new experiment that tests the nature of entanglement, and in every scientist who dares to ask, what if we're missing something? Bell taught us that it's okay to question the foundations, to not be satisfied with surface-level answers, and to chase the truth, even if no one else believes you. John Bell didn't have a fancy stage or a spotlight, but his quiet work changed how we understand the universe. It's a reminder that the biggest ideas can come from the most unexpected people. So if you ever feel like your questions don't matter, or that no one's listening, think of John Bell. Keep asking, keep exploring, and keep thinking differently. If you enjoyed this story, give it a like, share it with someone who loves science, and don't forget to subscribe to the channel for more amazing stories like this one. Thanks for watching, and see you next time.